Namaste. Welcome to Network Protocol module, which is the module in the network portion of digital library. In the ICT of digital library, we have already discussed the basic concept of network, the network topologies, and the fundamentals of data transmission, cell switching, packet switching, media used, security to be taken care in network, etc. As we have already learnt, network is the interconnection of computers, and the network can also establish between the other networks. In all these sessions, we have seen that various technologies and architectures are used in network. The technology varies from one network to other network, but the data transfer from one point to other network is the same. For example, if you want to transmit your own photograph, exchange your image, which is created in one network, has to go through a lot of other intermediary network before reaching the target network. So a user may not be aware that what are the intermediary network technologies used in between. In this context, there should be a common agreement or set of convention or rules that has to be predefined on each network, how the data transmission is to be taken place. In this context, network protocol, a module which will be covering about the fundamental issues of transmitting data over various networks and what are the common protocols available or popular protocols available, proprietary of protocols, and the standard models, which is even the TCP/IP model, OSI models, and also it will focus on, based on this model, what are the other protocol for data retrieval and search mechanism. So that will be covered in this network protocol module. In addition, the other protocol used, generally these are used on internet, like mail transfer protocol, SMTP, telnet, FTP, HTTP. This also will be highlighted in this module. So let us see what is a network protocol. Already noticed in many contexts, this word is commonly used in army, military, police department, even where hierarchy is followed. The literal meaning of protocol means what is to be done in a particular context when a VIP person comes. That is the literal meaning of protocols. Now, assume that a man who talks only Chinese language is interacting with an Indian who speaks Hindi. And let us guess that both of them know only one language. Chinese man knows only Chinese language and Indian knows only Hindi. How does the communication takes place? So you will all agree with me, we should have a common language to communicate each other. A translator can do the job in the context of language. That means a common, maybe somebody who talks English can be a translator in between, who can understand both language and translate. On network, this kind of translation is not possible. When data is coming from one network to other network, we cannot translate the data for the other network. The only possible solution for this is we predefine the set of sequences, conventions, and rules. If I send a data, that has to be in this manner, that is to go with this details, all this can be predefined. So that is what is the protocol or network protocol does in a network. So what is a protocol? Protocol is a code of correct conduct, that is the meaning, set of rules and convention for sending information over a network for exchanging data, controlled sequence of messages that is exchanged between two or more systems to accomplish a given task, define a sequence together with the format or layout of the messages that are exchanged, or a standard procedure for regulating data transmission between computers. Hence, network protocol is a set of rules that governs the communication between computers on a network. We have seen already there are networks which are called LAN network, a network in a small organizational setup, that is local area network, LAN, and in a city, that is metropolitan network, or create a private network, VPN, or virtual LAN, or wide area network, and ultimately the global network of network, that is internet. So network protocol defines the various processor and transmission of data between these networks. Let us discuss the evolution of various models. I will be using protocol and models because some of the protocols are known as models also. In 1974, the major IT company IBM built up their own network, which is called SNA, System Network Architecture. This was a proprietary model used by only IBM. IBM mainframe computer was a major computer which connect with the different peripheral nodes. So they defined their own architecture, and this came as one of the almost first network model by a company. In 1975, Decalpha, which was one of the company that time, they also defined an architecture for network. That is called DNA, Digital Network Architecture. This company is digital equipment company. So their model is called DNA. This is again a different kind of network model. So from company to company, the architecture, though it is exchanging data, but it differ the process of communication between the computer over the network. And in 1977, the most popular model, the 7-layer model, was introduced in the network. That is called ISO OSI model. The ISO stands for International Standards Organization, and OSI stands for Open System Interconnections. This is one of the very popular standardized, and even it has come out an open model in the network. Even today, Internet adopted some of the responsibilities and tasks defined in this model and combined it, and that has given birth to the new model called TCP/IP. TCP/IP stands for Transmission Control Protocol, and IP stands for Internet Protocol. And you must be already listening to IP address. Internet IP address is the unique address which recognize or identify an individual over internet. So this IP address, this IP came from this TCP/IP protocol, which is the latest protocol introduced in 1983. The proprietary protocol will not be discussed in details. You can read it. You can go and search in Google about this IBM, SNA, DNA, etc. because these are proprietary model. But many of the common mechanism of working of this model and protocols are same. So it is easy also to understand once you know about one model. I will try to explain the popular model ISO OSI, the Open System Interconnection model, which uses 7 layers, which is used for data communication. The 7 layers of OSI model defines various responsibility at a different layer when an application is passed on to network. The top 4 layers that are basically application oriented layers, and the bottom 3 layers which are generally network related layers. These 3 layers are available in almost all network equipment such as routers, etc. Now the first layer, that is the bottom layer, is physical layer, and the topmost layer is application layer, which deal with the application directly. In between this, each layer does its own job. The layers are independent to execute its tasks and pass on to the next layer. This is why it is called layers. So layer has a distinguished feature of executing its task independently and pass it on to the higher level of layers. I will just spell out all the layers now, but it is not that easy for you, the novice and new students, to understand and recall all the names. But I will introduce a technique now. The physical layer is the first layer, application is the last layer. Over physical layer, it is data link layer, then network layer, then transport layer, then session layer, after that presentation, and finally application layer. Now to remember this, there is a small phrase that like this. Remember, all people seem to need data processing. All people seem to need data processing. So all is for application, people for presentation, seem for session, to for transport, need for network, data for data link, and processing is physical. The phrase can be remembered. Many a time when I discuss this with the network students in the initial class, they may not be able to recollect the layer as it is. But once the responsibility is learned, as you can see in the slide, what A does, A want to communicate with another computer B on the network. As it is seen in the picture, A tried to give the application to the first layer, that is application layer, that is the process will interact with application. In the left side, as you mentioned, application will pass on to the presentation, then into the session, then into the transport layer, network, data link, and physical. In the physical, as the name implies, physical stands for the physical connectivity. The cable comes in the physical layer, hub come in the physical layer, so connectors come in the physical layer. So all the physical equipment, the standards, its specifications, configuration, working nature, methodology, everything is spelled out in the physical layer. So physical layer is slightly different from other layers because it works on the network in the physical media, and in that media data is transmitted as signals, because as I mentioned, physical layer is about cable. Cable is not transmitting data as it is passing only signal from one point to other. So physical layer transmit only signal. Till it reaches the signal from the application, the various processes been done at various layers. Through physical layer, it then in the other mission, it again goes to the data link network and transport back to session presentation and application and given to the computer B. So data from A is transmitted to B. Intermediately, all this OSI model works, execute its responsibility, and the network process is getting over and the data is transmitted. Now let us look at a little more details on this. As I mentioned, it is not required for a man who understands the concept of networking to by heart the different layers, because once you understand the responsibilities required, then all this layer will be serially in the same order as it is mentioned will be there in your mind also. Now let us take the first 7th layer, that is application layer. As I mentioned, the responsibility of application layer is communicate the network process. What is a network process? Any application which need network resource is a process. For example, email. In a simple computer, email does not have any value. It has to go to the other computer, other user. So email is a process which it need network. So we can tell that email application, that is SMTP, the protocol, is a network process or application, and that will give to the application, and the application layer will give to the presentation layer, where data is represented in a particular format. If encryption is required, that is also done, and all the formatting of data is done in the presentation done. So application will, if compartmentalize or encrypt, decrypt, whatever is possible, that is to be done on the physical layer. This presentation layer, it is to be done on the presentation layer. From there, it goes to session layer. Session is between the communication. There should be a host to host, inter-host communication channel. That is established at the session layer. Till that, it is only application and data. Now, session layer established inter-host communication. Then transport layer take care of the quality of service of these connections, that is end-to-end connections. Then network layer gives the address of each computer, that IP address, generally IP to MAC address. Physically, every computer is having a single address. The network layer gives an address, and also network layer decide the path. And there are a lot of responsibilities for this layer, and maybe I can say that out of these 7 layers, this layer is one of the very, very important layer in the OSI model, because that determines the path which resolves the IP address and which also address the IP address. And in the next layer, you can see that it is physically mapped, IP address is physically mapped to an IP address. The physical address is the IP address is. Physical address is the MAC address. Every network equipment will have a physical address. That is called MAC address. Generally, it is 48 bits, while IP address is 32 bit. That is given as an identity for all the users. So one machine, it is possible to have more than one IP address also. But network device, that it is unique in the world and can have only MAC address. So these two address resolution, etc. is addressed by network as well as the next layer, data link layer. So access to media is the responsibility of data link layer. And if it is done, what is finally required, once the mission is identified, physical where to transmit is identified, now as a signal the data should go to that machine. That is done in the binary transmission of the physical layer. That is the 7th layer. So all the 7 layers application. And I have a better slide to show you in the 7 layers of execution. As you see this, it's a beautiful picture I have taken from internet, where I have given also the source there. This one, the cable, the data transmission is in the physical form, which is the media signal and binary information is addressed in the physical layer. The signals will carry on and off signals, that is up and down signal, that will be denoted as zeros and one. That is the basic of binary transmission over in a network. Then physical addressing, like MAC address, example is given there. It is a hexadecimal addressing scheme. As I mentioned, 48 bits are used in hexadecimal form. MAC address is used for physical addressing in data link layer. After that, it is network, the path determining and logical addressing. IP to MAC address, all this is addressed at the network layer. The host communication, end-to-end connectivity is established. So a picture is also given to understand the process and responsibilities in each layer, transport layer. Then inter-host communication, that is the channel established between two hosts, is in the session layer. Then data representation and encryption in the sixth layer. Then network process to application. So in nutshell, right side, you can see that all the layers and some of the technical terms used. Suppose if I am talking HTTP. HTTP is a web protocol, web accessing. It's a browser based protocol used for displaying web pages. HTTP. So that is an application protocol which is mentioned in the top of that, www/http, that is there. And domain name resolving, DNS, when I give somebody's name www.google.com, it is resolving with an IP address. That is an application's job, DNS, domain names. Email, POP, SMTP, Telnet, FTP, all these are application layer protocols. So I have mentioned it never almost equal to the application layer. Then encryption, formatting, etc., recognizing data, JPEG, MP3, AVI, doc, all these presentation things are defined by presentation. The next level you can see that socket, session establishment in SIP, RTP, real-time protocol, all these are in the session layer. Then comes to transport layer, TCP, UDP, SSL, TSL, all this in transport level. You can see that TCP is given here, transport layer. And we will see in the next model, that is TCP/IP model, some of the layers are put together to create the TCP/IP model. That's why I was telling that OSI model is a basic model which even can give birth to the TCP/IP model later, which becomes the backbone communication protocol in internet. So whatever we see right now on internet is TCP/IP based. And how TCP/IP can configure, that also we'll see later. Now data link layer, I mentioned MAC and LLC, VLAN, ATM, fiber channels, frame relay, what kind of technology or techniques are used, HDLZ, token ring, ARP, Ethernet, Wi-Fi 802.11, WiMAX, that is 802.16, all this is almost mentioned in the data link layer. And the physical layer, this RJ45 connector, the CAT cable, 100 by TX, RS232 connector, that is the serial connector, all these standards are mentioned in the physical layer. This is how the layers works in the OSI model. And once again, recall it immediate data flow. I will just take you with the process M. Passing M stand for message, passing to computer A. What happened? It's a process. A want to send M message to computer B. B is in the right side. Computer A is in the left side. And router, that is in between. There is a router. So I have already mentioned router works with the 3 layers: physical, data link, and network. Computer works with all 7 layers. Now application layer, it passes message to the top layer. Then each layer adds a header, H1, information to the message, pass it to the next layer. And the next one will be addresses or checksum. That is H3 is added to this. Then H4 is added. Finally, H6 is added. H7 is added, and message is transmitted physically. The last, what you see is physically transmitted to the next network equipment. Now, the network equipment, it goes with the 3 layers, physical, data link, network, so that routing will be cleared on this. Router works on this. I mentioned that all these 3 layers works in the router. So router receives the message on this end and decide where to send it by checking the header information. then decide which device it has to pass on, then pass on to the destination. It understood that B is connected on particular day, and that is sent to that. Finally, the message reaches to the computer B. So this is how layers works for flowing data in the network, and this is one of the network model or protocols used. Now let us discuss the most popular recent model, TCP/IP, which is introduced in 1984 by Windsurf. Since this model is accepted for the internet communication, the man who has given this idea, Windsurf, even is treated as the father of internet. Transmission control protocol and internet protocol. So whenever we say two protocols we combine together, TCP and IP. And the naming is done such a way that TCP and IP, these are only two protocols. I must say that there are 100 plus protocol in this suite. So whenever we are referring to TCP/IP, rather than it is a name, this is referred as TCP/IP suite. That is a complete pack, TCP/IP complete pack with so many protocols, a glue of protocols. So I will show some of the major protocols on this. But TCP and IP is taken for the naming convention, TCP/IP. That's why we are mentioning as TCP/IP. So TCP/IP is one of the core network protocol on top of which most other protocols are built. So when I am talking about HTTP, there is a relation between HTTP and TCP/IP. Anyone who uses internet in browser, you used to generally type http:// then address www.inflimnet.sc.in. So many may not be aware that what is this HTTP. And HTTP is a protocol, an application protocol, and over TCP/IP. That's why this statement, the core network protocol on top of which most other protocols are built. TCP watches network traffic to detect problems, ensure that data is safely transferred between the network devices. Now, TCP/IP protocol suite. Let us see what are the other protocol on this. We have FTP, HTTP, SMTP, Telnet application level, MIME, BGP, UDP, ICMP, IGMP, OSPF, RSVP. All these protocols are inbuilt, or it is already included in the TCP/IP suite. That's why we are calling TCP/IP suite. So expansions are given on my slide. I may not be able to explain each protocol in detail here. As FTP, you know that FTP stands for File Transfer Protocol. Internet, one file is transferred from one point to other through FTP. So you will, many of the time, the big files you generally do an FTP rather than HTTP. That is file anonymous FTP. Accounts will be created in the server. Password is not required. So you log in there with FTP protocol, then download it. So instead of HTTP, browser also you can type FTP://. Then it will use that FTP protocol. But the default protocol in browser is HTTP. That's why we need not even type HTTP:// in browser. Just typing www.google.com, that also will work. Because browser, if nothing is mentioned, it takes that it's an HTTP by default protocol. So border gateway protocol is there. ICMP is there. ICMP is the control message protocol, internet control message that will give error message and information message on internet. That is the ICMP. If a machine is connected into internet, etc., we can use a command called ping to another machine. So ping www whatever is the name, xyz.com. You can execute with in your computer in the normal text mode command. You can use it. Run command, you use it, and ping. This ping uses ICMP protocol, which is also part of TCP/IP. So without knowing many of the protocol, we are generally using all this in our computer. Then SMTP is mail transfer protocol, and POP3 also is there, which is not mentioned here. SNMP is the symbol network management protocol. If your device is to be managed remotely from some location, well, I take an example of that. You have a Xerox machine where an IP can be given, and this can be switched on or switched off. So you need a protocol there, an application protocol in that machine, Xerox machine or refrigerator. Now many of the equipment comes with the possibility of networking on the internet. So all this is possible because it manages, all this are managed by a protocol called SNMP, Simple Network Management Protocol. So that protocol can be used to manage the network devices remotely from other places. I can switch it off. I can, like your AC is, if you're having an SNMP network, you can switch on the AC. So that is the possibility of using these protocols, and devices are now coming up. But all these are part of the main TCP/IP suite. Now TCP/IP, unlike OSI model, the major difference, as you can read from my slide, it is having only 7 layers. So can you quickly just look at the slide and tell which are the layers which are not available in TCP? Many of the layers are given there, but it is merged. So you can see that first one, physical layer. Instead of that, there is only one layer called network interface. All technology, Ethernet, token ring, WAN ring, serial, frame, AT. So last 2 layers, physical and network layer, is combined on that. The other network layer is named as internet layer, where IP is given. Then transport layer is there. We do not have presentation and session layer here. Instead of it is Windows socket NetBit. All these are called one layer called application. So in TCP, we have only 4 major layers instead of single layer in OSI model. Now this layer, how it works? Similarly, we have seen earlier, application layer, the similar. There is no difference. All the applications which works on that application, session, presentation, all combined together. Then transport is there for quality of service. Then network is there. After that, network interface. So SNMP, DNS, and all that you have seen that as application layer, and the rest of the things will be similar as OSI model. And transport layer is having 2 major protocols, that is TCP and UDP. UDP is datagram packets. TCP is generally it is packet. So TCP, there is the packet size is not restricted. So UDP packet and TCP packet, these are the packet creation in the transport layer. And network, as you mentioned, see right side, IP, ICMP, ARP, RARP, RIP. All these are the protocols in the network layer. And you may be wondering how a user get access to this protocol. TCP IP configuration can be done by a user. Go to the control panel and network configuration menu. There you get what is available in my screen, is like a screenshot of that, where you can select the TCP IP and right click and see the properties. So you will see that configure TCP IP. And if it is to be dynamic, you need not configure anything. Obtain IP address automatically say this. So if your network is having DHCP, it's a protocol again, DHCP, Dynamic Host Handling Protocol, DHCP. If that is working on your network, all machine will automatically take IP address from that. DHCP is for that purpose. We need not configure individual machine. But if you don't have DHCP, we have to configure our network device with an IP address. So this will show in a computer how to configure. As the screen shows, you have a configuration of TCP IP. I am trying to use a static IP address. Static IP address can be local IP address, that is LAN IP address, or it can be a public IP address, so that others public can directly come to your, but you need an internet IP and you have to register for an IP address. Then you can use the IP address given by your ISP on this. Now here I have given an example. First, the right side local. I am using a network where I can configure up to 255 nodes. So I am using 192.168.1.1 as my gateway, default gateway. That is the third. And I am giving for my machine 192.168.1.21. Then subnet mask. The details are not required now. In local area network, subnet mask is 255.255.255.0. Suppose if I use only 32 IP address, then this will be 255.248. So or 242. Similarly, that will be given by the ISP if it is a public IP. Here I am using a public IP where 255 or 248 subnet mask, because only that many IPs are allocated to me. So I put a subnet mask there to restrict my IP address. So I can use 12, 13, 14, etc. So here gateway is 1, 10.12.21, 212.1. And another configuration required is DNS. If I search for a name, your computer will check for whether this name is available or not. So your computer should immediately go and check for the name in a server called DNS server. So here I have given a global DNS address 8.8.8. or 8.8.8.8. So 4 times 8 and 4.4.2.2. These are the global DNS server. So I have used it. I think 8 is used by 8.8. is used by Google or implemented by Google. So Google servers are generally available all the time. So people even configure this as an IP address, and your ISP also will give their DNS server address. So that has to be configured here. This is how TCP/IP is configured in a network. So this is for the non-information purpose. In this slide, we can even configure the TCP/IP setting on our computer. Now let me pick up few protocols which are very commonly talked about, like application layer. You have HTTP, which is a browser-based protocol. HTTP stands for Hypertext Transfer Protocol. This is defined by IETF. All engineering or internet standards are defined by Internet Architecture Board. There is an Internet Engineering Task Force that defines that this has to be the standard on browser. Then HTTP becomes a protocol accepted by this, and that will be if somebody asks what is the protocol of the World Wide Web, www, and HTTP is the protocol of www. This works on two principles. One is request and response scheme. I ask for a request, I type something. If it is available, it will give on. It can display the content on the browser. We cannot use this protocol in any other program. It can be used only in browser. So it is available in all platforms. It is a text-based simple protocol, and adequate security is there. But for higher security, you have to use HTTPS. That is the secured model of HTTP. And basic is that client connects to a HTTP server. I generally put all my web pages in my web server. HTTP server is web server. So all my web pages are in the HTTP server. So when client requests for it, server sends an HTTP response. So request and response principle, it works. And once flow is over, connection is closed. And generally this request and response consists of a request status line, header, empty line, and whatever optional body is available. So HTTP work with the browser. So this is the request structure. HTTP has a get method, post method for request and get, and head method, put method. These are some of the things. While if you are making doing or writing programs, these kind of commands can be used in your program. Header with the optional header fields, content length and body. And as I mentioned, secured portion is HTTPS. So this is one of the protocol for web pages used in browser. And error messages response, if it is not found, it gives an error message. The popular one is like you might have seen some of this, request timeout. I tried to connect with a web browser website, and my traffic is not flowing the way I think. After sometimes it gives that it's not able to. So timeout message 408 is a request timeout, and if there is an error it is 403. If page is not found, 404. So some of the things, and if you are trying to access a site which is blocked, it is forbidden, 403. So HTTP gives this kind of message code which will browser will take its own display that I got this code, so this is going to be the display. So some errors are there. So this is one of the things. Whenever you try to browse a web page which is not available, the page cannot be found, message comes appear on over your browser. What is that? If in down you can see it's an error message of HTTP 404, file not found, the file which you are looking. So you understand that the file is not there, site must be working. So by seeing the error message also we can understand whether this website is having this page or not, or what kind of error it displays. And this is a get request example. When search you put a question mark and how all these things can be given. So it's a kind of, as I mentioned, pure simple text messages. This is a post request examples. HTTP response examples, what it returns. If it is okay, it gives with okay, then connection close, date and time, then which browser it is requesting. All this can be got it. And that in summary, it supports all platforms. Simple text-based protocol usually gets along with the firewalls. And the other one is SMTP, which is used in mail, simple mail protocol. As HTTP is used for web pages, SMTP is used for email. It is usually used for outbound emails such as email notification. And by default, this protocol uses UDP, and you can use post POP for fetching mails, or IMAP, Internet Message Access Protocol, in your mail client to read the mails from the mail server. So there will be an SMTP agent, then client, and SMTP works with different port numbers. This is the architecture model of SMTP communication model. Sender want to send a request to the recipient. What are the senders? Sender use an email client. The other man also use a client for reading mail. So email will be created in an editor, or like Outlook Express, or even the other thing like Google etc. have Gmail etc. having its own interface. Hotmail, Gmail, Yahoo Mail, Rediff Mail, all these are having their own interface. So that interface, but basically when you compose a mail, it goes to this protocol, POP IMAP client, and from this will go to the server, then it goes to the SMTP server, then the sender's local SMTP, it's sent to the other SMTP server. Then recipient, also the similar process. So this picture is, you can look into half and other side half, and the mail get transferred from one area to other. So SMTP is the basic internet based mail protocol, which is part of this TCP/IP in the application layer. Then few other protocol, as I mentioned, DHCP is mentioned already, dynamic host configuration protocol, which gives IP address dynamically to the host. If DHCP is available, if I carry my mobile and tell that I want to automatically connect it, I put it, the DHCP server will send an IP address to me, so that I get connected immediately. I need not wait for somebody to configure my system. So that is the DHCP protocol. Then file transfer mentioned, HTTP mentioned. Then there are news bulletin uses NNTP protocol, network news transfer protocol, then service location protocol, then terminal emulation protocol, that is telnet of TCP/IP. Telnet is used for remotely connecting to a server. If I want to log into a server from a remote machine, I use this command telnet. So telnet is also protocol. Then I will end with two protocol which are not generally communication, which are used for information search and retrieval. That is harvesting protocol. One is OAI PMH, Open Archives Initial Protocol for Metadata Harvesting. So this and Z39, that is a search protocol. With that, this module will be finished. I do not have much time to discuss more about every protocol, but you can just see the protocol name, Internet Control Message Protocol, which displays error messages and information messages as I listed out, and Address Resolution Protocol, which generally resolves MAC address to IP address. Two machines are connected, how it is done you can see from this slide. Then reverse address resolution. One is MAC to ARP is IP address to MAC address, RARP is MAC address to IP address. So that is, and DSCP, all these details also can be obtained for reading purpose. I will be giving some of the reference at the end of the course material. These two protocols are entirely different, and in library these two protocols are used very much. One is for metadata harvesting. You know that what is a metadata. If I create a content in the internet, it could be a book data or thesis data or a ebook data. So data about the data, that is what you call metadata, like author, title, etc. metadata. And any information we store with the metadata content. If metadata is available, this protocol will help you to harvest from other server. So OAI-PMH, it's a part of Open Access Initiative protocol for metadata harvesting. OAI-PMH, very important protocol in library science area. This protocol uses for metadata harvesting. It's provide a standard protocol for the harvesting and querying of metadata. So we must be having repositories with content. Repositories and harvester makes data exchange between the other servers and users. So from data provider, this will work like a service provider. And beauty of this protocol is that OAI-PMH is also based on your HTTP and XML. So the harvesting can be done over browser itself. One of the prestigious project we use, Shodhganga, which is OAI-PMH compliant. You can harvest the metadata from there. So this slide shows a lot of repository, one repository, and harvesters can be anywhere. They can harvest the metadata, and metadata can link to the content in the repository. So this is an example, architectural overview. Harvester send request to repository using OAI-PMH, request for the metadata via HTTP, then repository reply with the responses to the harvester, and data is displayed. So OAI-PMH is a protocol used for data exchange for harvesting metadata from the repositories. The other protocol that is used for search and retrieval of information is Z39.50. This protocol provides interoperability of search and retrieval of information. One platform you can move to other platform, interoperability for search and retrieval of information with the client server systems. This is a standard established by National Information Standards Organization. Later it is accepted by ISO, and whenever ISO accept a standard, they give a number for that. So 23,950 was the number given, but we use that Z39.5, last 4 digit is used with a dot, and this standard is maintained by Library of Congress. That's what I was telling. These two protocols are extensively used in library. In addition to these two protocols, there are open standards. You must be aware that the document file you create 20 years back cannot be read in any platform now, any software now. This is because the standards get changed. WordStar was one of the package used earlier for creating word processing document. Now WordStar is not used. The document created in WordStar also cannot be read because we did not use an open standard. Now also people are using docx, all this. These are not open standard. So we can't say after 5 years whether this will be used. So instead of that, we can create documents in PDF form, which is an open standard. So such kind of standards are there. So in applications, you can have application independence if you are using open standard, platform independence if you are using an operating system, interoperability, which allows the data exchange, and also coherent architecture model, because it is an open standard, anybody can work on it and exchange of data is possible. So in nutshell, we should use open standards. Few open standards are like PNG for image is a standard, XML is an open standard. As I mentioned, PDF, CSS is a cascading style sheet, MPEG is an open standard, JPEG is a open standard, unique for languages, regional language is an open standard. Now recent RDF, H264, all these are coming as the open standards, examples of open standards. So to conclude, we have discussed about protocol, network protocol. In network protocol, we have also discussed the basic protocol used in network, application protocols, the other associated protocol. So started from OSI model, TCP/IP, then coming into that SMTP, HTTP, basic, and this slide, the last slide shows so many protocols in various area, in various levels, transport layer, application, internet layer. So any protocol, if you happen to know, first to see that in which layer it works, then try to understand the responsibilities as well as the use of that protocol in the network. And 90% of protocols are used now for internet purpose, because internet has evolved as one of the largest world network. So understanding about network protocol can help you to understand the data exchange, information exchange, which is the primary or basic responsibility of a librarian. Thank you.